Now that you've learned all of the kinematics formulas, it's time to move on to dynamics. Up until now, we've only been concerned with the motions of objects, but dynamics is concerned with the forces that create those motions. In dynamics, the main formula that you need to remember is force equals mass times acceleration, or really, the net force acting on an object equals the mass times the acceleration. This is known as Newton's second law of motion. What this formula tells us is that an object will only accelerate if there's a net force present. If there is no net force, the object will either remain stationary or move at a constant velocity. This concept is known as inertia, and this is Newton's first law. As a quick example, suppose that there's a box being pulled to the left with a force of 2 newtons, and that this box is also being pulled to the right with a force of 5 newtons. Suppose that this box also has a mass of 5 kilograms. We can find the net force by adding 5 newtons to negative 2 newtons, which gives us a value of 3 newtons. Newton's second law then tells us that 3 newtons is equal to 5 kilograms times the acceleration of the box. Solving for the acceleration, we find that the acceleration of the box is 0.6 meters per second squared. If the force pulling the box to the left was 5 newtons, we would find that the net force was 0, and Newton's second law would tell us that the acceleration was also 0. The box would then remain stationary. But because there is a positive net force, we see that there's also a positive acceleration in this case. The weight of this box also represents a force. From Newton's second law, we see that the force due to gravity is 49.05 newtons. You might think that the force of gravity represents a net force in the negative y direction. But if this was the case, how could the box be stationary on the ground? If there was a net force present, the box would need to be accelerating through the ground. This is where Newton's third law comes into play. There is actually another force called the normal force that opposes the weight of the box. This force is equal and opposite to the force of gravity, which allows there to be no net force in the y direction. However, this force is only present when the box is resting on the ground. I hope that this gave you a basic understanding of dynamics, as well as an understanding of Newton's first, second, and third laws of motion. I'll cover more in my next few videos, but know that Newton's second law is a very important formula in physics. Understanding this will give you a basis to understand more advanced topics. I hope that this helps, and thanks for watching.